Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem, just attempt to solve it, talk through my thought process, and hopefully it's useful to someone watching this. So the problem I'm going to be attempting today is from LeetCode's LeetCode 150 set of problems. So the problem I'm going to be attempting today is problem number 15. I'm just going to read out the description here. So, given an integer array nums, return all triplets nums I, j, and k, such that I is not equal to j, I is not equal to k, and j is not equal to k. So all the elements are different, and when they're summed together, it equals 0. Notice that the solution set must not contain duplicate triplets. So you've got this set of numbers, and you have to return all the triplets that will add up to 1. So minus 1 plus minus 1 is minus 2. Oh wait, minus 1 plus minus 1 is minus 1 plus minus 1 is minus 2. Yeah. Minus 2 plus 2 is 0. Yes, okay. Minus 1 plus 0 is minus 1. Minus 1 plus 1 is 0. Okay. Yes. So that is the spec, and looking at the given hints, there are 3 numbers, x, y, and z, added up to a given value. If we fix one of the numbers, let's say x, we are left with the 2-sum problem at hand. For this problem, if we fix a number, say x, we have to scan the entire array to find the next number y, which is value minus x, where value is the input parameter. Can we change our array somehow so that search becomes faster? The second thought of train for 2-sum is without changing the array, can we use additional space? Okay, so based on these, I'm just going to switch over to my notes and write down some ideas. So, think what the best thing to do would be to just take this here. So we've got nums. Okay, so we're going to use the same method as before, and if I can find it and also have it open, that would be good as well. Yep, this is from the previous video. So I'm actually just gonna take this and put it in here. So if we are using this method, we have 2 pointers, but we need to look at 3 things. So I'm not entirely sure how we're going to do this. We could have like 3 pointers. What we could do is, it says we can fix one of the values, so have a pointer iterate through all values in nums. So we're going to have a pointer that does that. And then we're also going to have a left and right pointer. We're going to still sum the values at left and right pointers. And we're also going to call this pointer iter. We're just going to call it iter. Some values at left, right, and iter pointers. First of all, we need to check that each pointer is at a different position. Check if pointers point to different elements. If they are different, some values at left, right, and iter pointers. If it is above 0, move the right pointer towards middle. If it is below 0, move the left pointer towards middle. If it is equal to 0, append output with nums left, nums right, and nums iter. Okay, and then what we're going to do is repeat until looped through all numbers. Okay. I'm going to copy and paste this into here. So, left is going to be equal to 0, and then right is going to be equal to length of nums minus 1, and iter is going to be equal to 0. Iter pointer, we're going to call it. Okay. So for num in range, length of nums, so for each number, check if pointers point to different elements. So we're going to actually have to initialize this every loop, basically, not the beginning of the program. So up here. In fact, we don't even need this iteration pointer. We could just use the num value here as the pointer. So if num isn't equal to left isn't equal to right, in fact we'll do it like this. We'll use the same sort of logic here. So we'll say I is left, j is right, and k is num. So this is if they're different. Sum the values together. So sum pointers is going to be equal to left or nums left plus right and plus num. If sum underscore pointers is above 0, left minus equals, or if it's above 0, move the right pointer towards middle, so right plus equals 1, some underscore pointer is less than 0. Move the left pointer towards middle, like that. If it's equal to 0, else elif some underscore pointer is equal to 0. Output dot append this. Okay. So I'm just going to run this and see what we get. Comment this out for now. Just a syntax error there. Try run it again. Okay, so I mean here I got this right. I got these three summed together. Okay, here there are none. Oh wait, you have to keep on. We have to keep on looping somehow. I guess the lazy solution would just be to put it in a while true. And then a try. And it means that if it goes out of bounds, it's just gonna throw an error. And then you can catch. Is it try except? Is that what it is in Python? Yeah. Accept, continue, and it'll just go on to the next one. This is really lazy, but it should work. Unless it somehow gets stuck in the infinite loop somehow, yeah. We could say while left is greater than or equal to right. I guess that could work. Oh, sorry, other way, while it's less than or equal to. We're just gonna loop for like a set amount of time. We're just gonna run for this amount of times. The length of nums. Yeah, and it gets this out of range, so we could say, I don't know why we can't just say, while true, try all this. And then you just put an except here. And then you just say break. Timeout exceeded. We can say for I in range length nums. Try this. Except break. Okay, this is good for now. So yeah, none of these times get to equal 0. I think these should actually be the other way around. So if it's less than 0, you want to increase it, and if it's greater than, you want to decrease it. So it should be the other way around. Nope. If it's greater than, then yeah, you would move the oh, I think I see what I've done here. The right should be moving to the left, and the right should be getting added 1. So if it's greater than 0, decrement the right pointer towards the middle, which will decrease it. Yep. If it's less than 0, then increase the left pointer towards the middle, which will increase it. Okay. Let's try and do a dry run of this. So you've got -1, -1, and -4. So we do, these aren't the same, so we don't actually do anything if they are all the same. So if they're if left is not equal to right and left is not equal to num, um in that case, I guess you could check if, so we shouldn't need all this. So if the left isn't equal to the right and the left isn't equal to num, so we're going to say if left is equal to num, then we can do left incremented by 1, If right is equal to num, and right gets decremented by 1. Okay. Let's try this. Okay, and then I guess when we get to how many times will we need to run? And we can say while left is not equal to right, because there's going to be some point where they eventually cross over. So while left is not equal to right, do all of this. Hmm. Um. List index out of range. Hmm. Um. If left is equal to num, move left up by 1 towards the middle. If right is equal to num, decrement right by 1 towards the middle. The sum of the pointers is the left value plus the right value plus the num value. Print left, right, num. Let's see what it comes up with. So looking at the test cases, we start off with 1, 5 and 0. So 0, 1, 2, 3, 4, 5. So we got 1, 5 and 0, which is right. So 0, 1 and 5. Oh, I've not taken something into account here, and that is that these numbers are not sorted at all. So right here I'm just going to say nums is equal to sorted. That's something I just took for granted in the last one. Nums is equal to sorted nums. So the output limit got exceeded on this one. I think just because I'm making too many print statements. Well, yeah, it did. Yes, it got stuck somewhere. So it gets to the point where does it get stuck? So this is left, right in our iterating value. That's what it is. It gets to this point where the sum pointers is equal to 0. I think I'm gonna have to take a different approach to this. I'm gonna go back onto my notes. So I think there was a previous time where I'd done LeetCode 1. So I'm just gonna take the solution that I'd done for this and try and apply it here. So brute force, check if each of the numbers can be added with all the other numbers in the array to get target, but keep the number as you need to return indices. You have to do comparison checks to ensure you're not doing two values with the same index together. I'm going to also look at the hints again. So essentially I need to find three numbers so they add up to a given value. If we fix one of the numbers, say x, we're left with the two sum problem. For this problem, if we fix one of the values, we have to scan the entire array to find the next number y, which is value negative x, where value is the input parameter. Can we change our array somehow so the search becomes faster? Okay. Second train of thought is, without changing the array, can we use additional space somehow? Like maybe a hash map to speed up the search? Yeah, that makes sense here. If we fix one value, say x, we have to scan the entire array to find the next number y, which is value negative x. So if x is value 5, the next two numbers need to add up to get negative 5 to get it to 0. So let's take these, put them into notes. Okay. If we fix numbers, so we essentially need to find three numbers x, y, and z such that they add up to a given value. If we fix a number, say x, we're left with the two sum problem at hand. For the two sum problem, if we fix one of our numbers, say x, we have to scan the entire array to find the next number y, which is value negative x, where value is the input parameter. Can we change our array somehow so this search becomes faster? Hmm. This is a bit confusing. So, just looking at this, there's also this third hint that I'm going to copy over that says hint 3, the second train of thought is of to sum is, without changing the array, can we use additional space somehow, like using a hash map to speed up the search? So we could try that. Maybe try converting the array to dictionary. AG -1 is the key, and the positions where it exists are 0 and 1, 2, 3, 4. And then position or value 0 exists in positions 1. 1 exists in position 2, and etc. So if you want to find where the value 0 is, you can get that in O of 1 time. So that's one thing that we could do to start off with. So I'm going to go back here and make some more progress on this. Get this add away. So in fact, we'll keep this for now. So what we're going to do is we're going to turn it into a dictionary. So for num and nums, we're just going to call this num underscore dictionary. If num and num underscore dictionary, num underscore dictionary num plus equals 1, else num underscore dictionary, or other way around, sorry, num underscore dictionary at index num is going to be equal to 1. And then we'll just print the dictionary here. In fact, that's not what we're doing, we're not counting the occurrences. We're going to do dot append num, and then we're not setting equal to 1, we're setting it equal to num. And then we're going to be printing num underscore dictionary. Okay, so this is what we're wanting for now. And then what we're going to do is kind of do the same thing. So we're going to be looping through, so for this here, for num and range nums, we're going to be looking through the numbers. So for each number, so I'm going to call this x for x. for x in range of nums. So x is going to be this number that's going to be iterating through. Okay. We're going to print x as nums x. And then we're going to have y iterating through again. We're going to have, in fact, we'll call it I, j, and k just to make it similar to the problem. For j in range, length of nums. So let's try this. Needs to be a string to be printed. Okay. J is -1, j is -1. Oh, I didn't set this one to I, that's why. So, -1, then this will go -1, 0, then -1, 1. Okay. And then we need to find whatever's I and j added together, but the negative of that. So we need to find negative, and then so we need to find -2, so +2. So we could actually probably do if we were to put a negative sign here. Oh, and take this away. This wasn't closed. Run it again. Yeah, -1, so we need to find 2. So, if this is if this in nums underscore dictionary print nums underscore dictionary print this. Okay, num, there we go. Okay, so we need to find 2. Oh, we don't want to print this, we just want to print, I want to print the position it's at, so nums underscore dictionary, num. Or, no, not num, this. Okay, so exists at position 2, 0, 1, 2, which isn't right. So we need to find 2. Oh, we're not. Ah, I'm not appending the index, right? So for num in range length of nums, if nums num is in numbers dictionary, so this should be what we're looking for now. So we need to find 2. Okay, it exists at position 3. 0, 1, 2, 3. Yes. Okay, so we're getting somewhere. Since this is used so much, I'm gonna turn this into like a variable. So target number, or yeah, I'm just gonna call it target for now. Okay. So it looks like we're getting somewhere. So if it's found, we're gonna do for num in we could just say target. If target and num's dictionary print this. For num in the list of indexes, we're going to output.append. We're going to do nums I, nums j, and we're going to do, we're going to say this is k. I'm actually going to change this to k. Okay. Name output is not defined. I'll say that up here. List.append takes one argument. Okay, that's because I've not put it in a list. Okay. So I is j, k is minus, I is minus 1, j is minus 1. Add them together, you get, I don't think this is right. Let's see what k is. So k is 2, yes, that's what we want to find. Oh, we want to, for num and in fact, since it's if k is in num underscore dictionary, I'm going to print this as well. So we need to find 2. If 2 is in numbers dictionary. Oh, we should just print k. Okay, so minus 1, and 2, yep. Let's see if the rest are valid. Minus 1 plus 1 plus 0 is 0. Minus 1 plus 1, 0, yeah. Okay, let's we should also have the indexes. We should check if the indexes aren't the same. We're going to check if we're going to say for num in nums underscore dictionary k, if num or we'll call this k index. If k index or what we can say, if I does not equal j and I does not equal num underscore dictionary, or does not equal k underscore index output.append. I'll print these and then we'll do output.append the three values. A little syntax error. I've attempted to run code too soon. Okay. I'm also going to sort these as well so that it's easy to set them at the end. Put that in here. Nope. I don't know if that's the right syntax. I'm just gonna try using slicing to reverse it. No, no, I don't want it reversed. Sorry, I want it sorted. Dot sorted. Is that the right syntax? Dot sort. Let's look this up. Okay. I guess we maybe have to sort it. We'll just call it triplet. And then we'll print triplet here. Triplet is equal to this. Then we could do triplet dot sort. Will this work? Yes, that works. Perfect. Oh. I'm just going to comment these out because I might actually need them. Can do output dot append triplet, and then we're going to return this set of triplets. In fact, we can actually check here if triplet in output or not in output, then output.append triplets. So we're going to return output here. Let's see if this works. So I had to get the -1, -1, 2, and the -1, 0, 1, but this should not be here. Indexes, and then we're going to do I, j, and k underscore index. Aha, 3, 4, and 4. These indexes are the same. So just checking I is not, or j is not equal to k, the k index. Okay, these test cases pass. I'm going to take out this print statement here as well for now. Going to hit submit, and hopefully don't get a time limit, no time limit. Oh, that is very annoying. That's very, very annoying. Only, was that 2 plus 3, 5 test cases did not pass. Oh, that is very annoying. That's a lot of numbers to try and do this for. This is coming up on an hour, so I'm going to stop the recording here, and I'm going to do a second attempt on this, because I'd kind of said to myself that I'm going to spend an hour on mediums, so spent an hour, almost got there, so I'm gonna leave it for now. But thank you very much for watching this video. Hope it was useful to you in some way, shape or form, even though I didn't solve it. If you'd like to maybe give some suggestions in the comments, resources that I could look at, it would be greatly appreciated. But yeah, thank you once again for watching the video, and I hope you have a great day. Bye.